Okay, finishing up here in lesson 9.6, we're going to look at two rational inequality examples. Okay, steps are very similar to solving rational equations when there's an equal sign, with the exception of we've got to look at excluded values and things like that. But as far as finding the LCM, getting denominators to cancel out and things like that, very, very similar. So, inequalities, greater than or less than signs, rational inequalities that have fractions or variables in the denominator. So some steps here. We're going to list the excluded values, solve the related equation. It's actually going to be an inequality there. We're going to have greater than or less than sign, so we got to think about the inequality rules when we're solving. Use the values determined in steps 1 and 2 to divide the number line into regions, and I'll show you that. We're going to test a value in each region. To determine that. So I'll show you how to test a value here to satisfy the original inequality. But let's go to our first example here. All right. So solving a rational inequality. Notice, similar to a rational equation, we got variables in the denominator. Sometimes you might have a variable on top as well. We got an inequality sign, a less than sign in this example. Okay. Now, I have a couple steps listed here that are different from rational equations. As far as what you want to do, we still want to find the LCM of the denominators. What would be the common denominator? And then we're going to multiply by it, just like with rational equations. So if you look here, I don't have any plus or minus signs. I've got 3s in one of my denominators. I've got 9s in the middle denominator and 3. So I want to look at these numbers. I want to find the smallest number that they go into. So I would start with the big one, 9. 3 does go into 9, so I'm going to need a 9 on my LCM. Okay, because 9 would be 3 squared, and I'd need to take the 3 squared from those. Notice I have s and s. S to the first, I take the bigger exponent, well that's s. I want to multiply by an LCM, the lowest common multiple of those, so that denominators will cancel out. So here's what we have. We're going to multiply everything by 9s. Okay, and actually, let's do the critical value or the excluded value first before I get into actually solving what we're going to solve there. An excluded value is what makes the denominator zeros. Excluded value, some people call it the critical value, critical point. Okay, if you look here at these denominators, I have 3s or I have 9s. What would s have to be? Or if I take that first one, set it equal to 0, 3 times 0. So the excluded value in this case is 0. If s was 0, the denominators would be undefined. That's an excluded value or a critical value, makes a denominator 0. Okay, so s cannot technically be 0, but that's the excluded value that we want to look at. That's going to help us divide it into regions. So now we're still multiplying by the 9s. Let's cancel out denominators. Here's what I mean. Here, the s's cancel. 3 goes into 9 3 times. So I have 1 times 3 left, which is 3. Here, all of 9s cancels, so I'm left with plus 2. Over here, 3 goes into 9 3 times, so I have 2 times 3s left, which is 6s on that side. Now I'm just going to carry down my sign. It's less than. So I have 3 plus 2 are like terms. That's 5 is less than 6s. Well, I'm going to divide by 6. So 5/6 is less than s. Or that also means s is bigger than 5/6. Either one of these, the variable on either side, but the s is bigger than the 5/6. Okay, so what we want to do is we want to divide the number line, into regions using our critical value of 0 and what we got for the solution, which is 5/6. So this was the critical value in the solution. So I want to plot 0. 5/6 is positive, so 5/6 would be, I'm going to put right here, it'd be a little bit before if that was a 1. 5/6 of the way to 1. So what we've done is we've divided it into regions using our critical value, and so let's erase that. I'm actually going to take that off of there. Those values. Now we want to pick a value in each region. So here's what I mean by that. I want to pick something down here, so I'm going to pick something in the negatives, less than 0, so I'm going to pick -1. I'm going to pick something in between 0 and 5/6. I'm going to try 1/3. And then I'm going to pick something bigger than 5/6, so I'm actually going to try 1. You want to try and pick numbers that are easy to plug in. Now, here's what I mean by test values. Let me slide this down a little bit. So we're going to go to the original inequality, and I'm going to rewrite it here. It was this: 1 over 3s plus 2 over 9s is less than 2 over 3. So what we're going to do is we're going to do our test values. We're going to do, first of all, s equals -1. We're going to plug -1 in for s. So if I put a -1 in there, here's what I'd have. I'd have 1 over -3 for the first one. 3 times -1 down here is that. Okay, and then I'd have plus 2 over, if I put a -1 in there for s, it'd be -2/9, or 2 over -9, is less than 2/3. So I'm basically taking -1/3 plus -2/9. Okay, this is the same as -3/9, so I'd have -5/9 on this side is less than 2/3. Is that true? And that's true. So that kind of checks out. It's a negative number. It's obviously less than a positive fraction. We added 2 negatives there. So that's true. That means that basically when I graph here, that everything in the negatives to the left of 0 is going to check out. Let's do s equals 1, and then I'll plug in the fraction. So now I'm going to have, if I put 1 in, I'd have 1 over 3 times 1, or 1/3. It would be a positive 1/3. If I put 1 into the middle rational expression, 2 over 9 times 1 would be 2/9, and less than 2/3. So this would be the same as 3/9. So 5/9 is less than 2/3. Oops, 5 over 9 is less than 2/3. Okay, 2/3 is how many ninths? Well, that would be the same as 6/9 if I want to get a common denominator there. And that is true. Okay, so what this is meaning is everything where this 1 is, which is over here, is going to work. So everything that way from 5/6 over, and basically everything from 0 over that way is going to work too. Now, if you put 1/3 in, I'd have 1 over, so if I did 1/3, I'd have 1 over 3 times 1/3. 3 times 1/3 is 1, so that's going to be 1, plus 2 over 9 times 1/3. 9 times 1/3 is 3, so it'd be plus 2/3 is less than 2/3. If you can see here, this side's going to give you 1 and 2/3. Well, that's not less than 2/3. That's false. So in between here, I tried 1/3. That didn't work. So basically, if I looked at the graph of my solution, where we had 0, 0 and 5/6 on the number line, it would be an open circle here going that way, bigger than 5/6, and all these negatives less than 0. Now, if you're going to write the inequality solution, okay, that would be the graph, but I want you to write the solution. We're going to say, and the variable used was s, so we're going to say s is less than 0 or s is bigger than 5/6. Now notice s is bigger than 5/6 was what I got when I actually solved it right up here. But we also had to look at the values on the other side of the critical value. What's going to happen with rational inequalities is you're going to get your critical value and what you get when you solve the inequality. And what's going to happen is it's either going to be work for the numbers in between them or kind of go in opposite directions. Just a little helpful hint with them. So really, if you try one of the test values, that should work. But let's do this one here. So the critical value here, or the critical point, excluded value, whatever you want to call it, is x equals, now notice we have just an x and we have a 5x, so x equals 0 is our critical value or our excluded value. So we know it's 0. Now let's actually solve this. The LCM would be 5x. Okay, smallest number that 5 go into is 5, so we're going to multiply everything by 5x. Here, the x's cancel, so I'm left with 5. Here, 5x cancels, so it's plus 3. Here, the 5 cancels, so it's bigger than 2 times x, which is 2x. 5 plus 3 is 8, so 8 is bigger than 2x. We're going to divide by 2, so 4 is bigger than x, or that's the same as x is less than 4. Okay, I like to put my variable first, so now I want to look at, on the number line, my critical value of 0 and my number that I got when I solved the inequality, which is 4. Okay, now if you use the helpful hint that I gave you, it's either going to work in between or going in opposite directions to positive infinity and negative infinity. That's going to be the case. But if you tried like x equals negative 1 here, x equals 1. 1 and negative 1 are good numbers to try, and then let's try like x equals 5 over here, which is something bigger than 4. Okay? So let's see what happens. We're going to go ahead and plug this into the original that we had, which is 1 over x plus 3 over 5x is greater than 2 over 5. So let's go and plug in our first one. Let's try negative 1. So if I put negative 1 in there, I'd have 1 over negative 1, which is negative 1. Plus, if I put negative 1 in there, it would be 3 over negative 5, or negative 3/5. Is that greater than 2/5? Well, I'm adding two negatives, which is going to be negative something. That can't be bigger than a positive fraction. So I know it doesn't work over there. Okay, now if you listen to the helpful hint I gave, let's go ahead and try it here with the 5. I would have 1 over 5. So if I'm putting in x equals 5, put a 5 in there, 1 over 5, plus 3 over 5 times 5, or 3 over 25. Is that bigger than 2/5? Now you kind of have the common denominator here would be 25, so this would be 5/25 plus 3/20. So I'd have 8/25 on this side. If I had a 25 over on this side for my denominator to multiply by 5, so that's 10 over 25. Is 8 over 25 bigger than 10 over 25? No, that's not true. So that doesn't work. If you put 1 in, just to show you that it does work, so basically this is going to be one that's in between these. And these are going to be open circles because there's just a less than sign. Less than or equal to would be closed circles. So if you actually put 1 in, I don't have a lot of room to show this, but I'd have 1 over 1 for my first fraction, if I put 1 in for x, so that'd be 1, plus 3 over 5 times 1, 5 times 1 is 5, so that'd be 3/5. So 1 plus 3/5 is bigger than 2/5. You can see that that's going to be true. I mean, this is 1 and 3/5. That's bigger than 2/5. That's true. So what's working is these ones in between. So how do you write your solution? Well, it's in between two numbers. So I'm going to go from 0 to 4, and x is in between them, so we do this. So that's the solution. That would be the graph between them. Okay, so you cannot just write for this one. Notice we got x is less than 4 right here, but we got to take into account our critical value. So the numbers below that critical value are not going to work. That's why we have to write the inequality like this. I will not accept if you just write x is less than 4. You have to have the critical value on the other side. But again, a summary here is that in between there, it's either going to work in between your critical value and the number you got in your inequality, or it's going to work in opposite directions, going above that number or below the critical value in opposite directions. Okay, and then writing the inequality.